Hello. So, hi guys. For day 4, I'm going to start a new book, which is this is my notes where I'm updating all the notes which I read from this book there. So, this book name is Learning SQL. Contents here in this book are in the first chapter, Introduction to Database, Non-Relational Database System, Relational Model, some terminology, and SQL statement class, non examples of SQL. And in the second chapter, we are reading about how to create a database and how to insert values in those database tables, like different data types in MySQL, table creation, and populating and modifying the data tables. Query primers. I don't know what this means. Mechanics, query classes. Okay, we'll see all these. Filtering. This is the regular thing. Querying multiple tables. Working with sets. Data generation, conversion and manipulation. Okay. Grouping, aggregates, queries, joins, conditional logic, transactions, index, views, metadata. Okay. This is a preface. Okay, directly we'll start the chapter 1. Little background. Before we roll up our sleeves and get to work, it might be beneficial to introduce some of basic database concepts and look at the history of computerized data storage and retrieval. Introduction to databases. A database is nothing more than a set of related information. Telephone book examples is a database of the names, phone numbers, addresses of all living or people living in a particular region, while a telephone book is certainly a ubiquitous and frequently used database. It suffers from the following. Okay, finding a person's phone number can be time consuming, especially if the telephone book contains large number of entries. A telephone book is indexed only by first or last names, so finding the name of the people living at particular address is not practical. It is discussing about the previous early database systems where it is stored like in magnetic tapes, because there were generally far more tapes than tape readers. Technicians were asked with loading and unloading tapes for. I think this is not necessary. Just skipping it. Non-relational database systems. Over the first several decades of computerized database systems, data was stored and represented to users in various ways. In hierarchical database system, for example, data is represented as one or more tree structures. Shows figure This figure shows how data relating to George Blake's and Sue Smith's bank account might be represented via tree structures. So it is representing these two persons' bank account. Checking, saving. This person has these two accounts, and this person has three accounts. Checkings, line of credit, and money market. In each account, the transactions were like debit or credit transactions are there for each account. So it is represented in a hierarchical way for each customer uh, accounts are there and transactions are there. So it is now this configuration is known as single parent hierarchy. Right? This only has single parent. Another common approach is called network database system. Exposes set of records and set of links that define relationship between the records. So in this we have network database system. Like for this only single parent is there for any record. And we have a network like structure here. Mm, like customers is divided in this section: accounts section, transactions sections, and products. Don't know what this product means, but yeah, for each customer is related to accounts, and for each account transactions can be happened from to and fro. In order to find the transaction posted in Sure Money market account, Sure market account, you will need to perform the following steps: find the customer record with Sue Smith, and following follow the link from Sue Smith record to her list of accounts, and from here we need to see the list of accounts. Like we need to find this money market. Traverse the chain until you find the money market account. Follow the link from the money market record to its list of transactions. From here we need to find the list of transactions happen to this. Notice that each product record points to a list of account records that are product type. So let's come to this network. After finishing of the network model, this is a relational model. Um, uh, that propose the data be represented as a set of tables. So here in the relational model, we use tables. In hierarchy, we'll use a parent-child model. In the network, we use different networks and connections between them. rather than using as pointers to navigate between related entries. The redundant data is used to link records in different tables. Figure 1.3 shows how charge and use account information would appear in this context. Like for the customer table, we have this first name and last name information. Account table, we have all the account related things where these are related by using the customer ID, products and transactions. We have all the data is represented in four tables. Let's skip it. We all know the SQL thing. Terminologies used in SQL are entity, which is the name of the database, uh, like a table name, and column. Each columns present in the table. Rows means the data is represented in the form of rows. Table is known as a set of rows. Result set, it generates the result of an SQL query. Primary key, which is used to uniquely identify the row, and foreign key, it is used to combine one or more tables. SQL statement classes. Is divided into several distinct parts. SQL language is divided into several distinct parts. The parts that we explore in this book include several schema statements, which are used to define the data structure stored in the database. SQL data statements, which are used to manipulate the data structure previously defined using SQL schema statements. Example, to create a new table in your database, you would use the SQL schema statement create table, whereas the process of populating your new table with data would require SQL data statement insert. Okay, these are the statements. SQL create table all. To give you taste of what statements. These are all SQL statements. Just a minute. So, like here an SQL schema statement that creates a table called corporation. This is the SQL statement where we are creating corporation table, create table name, and the columns separated by comma, and the data types of columns. The constraints for column. These two are the column, and this is the constraint. This statement creates a table with two columns: corporate ID name, with the corporate ID column defined as the primary key. Here the constraint is mentioned primary key, such as different types of available with. And then it's chapter 2. Next, here after creating table, we will insert that enter the data information what we have: corporate ID name, values, all this will be entered. And when we fetch, we will fetch after inserting the data. Skill a non-procedural language. And we will interact SQL with another languages by using these tools. We'll interact Java using JDBC. Like there is an interaction between Java and SQL by using this toolkit package something. Sorry. For C++ to connect with C++, Rogue Web Source Pro DB and C or C++, MySQL API Pro Star C, etc. C Sharp, .NET, Perl DBI, Python DB, Visual Basics. Select one or more things from one or more places and conditions. I will just sign in and come here. Just sharing my screen. Just a minute.